Uh, Hi Mayank, are you here?
Good evening, ma'am. Uh,
Good evening. Actually, my name is Jyoti Sharma, and I will be the teaching assistant for this class, right?
okay, ma'am.
Yes. My voice is audible to you or not? Is it clear or some harsh?
Ma'am, it's clear.
Okay, then thank you. Let someone join so that we can start the class after 2 or 3 minutes later, right? Mayank is here. Anshu, I know Anshu from BHU, and then I don't know Anurag. Yes, I know Momita because Anshu and Momitas are two friends and from BHU only, right? Yes. Let's wait 2 minutes more so that people can join us. Then we will start our class. Okay, I think we should start the class. Mayank, what's your background?
Ma'am, I am a student of computer science engineering from NSUT Delhi. Uh,
From where?
NSUT Delhi.
Okay, NSUT Delhi, right?
Yes, ma'am.
Okay, and you want to prepare for the UPSC or something like that. That's why you are joining this course.
I was too bored of coding and stuff, so I decided to hop on to humanities subject and explore. That's why I enrolled in this course.
Okay, so have you taken SIR's class till now, or you didn't take this class? This
Yes, ma'am. I attend them regularly.
okay, then it will be fine. You will help me while answering the question, right?
Yes, ma'am.
Okay. Momita, are you here? Momita,
Yes,
Anshu.
ma'am.
Okay, then fine. Anshu.
Yes, ma'am.
Okay, okay, let's start the class and then we will proceed further. Mm, Let me share the time. Is it visible to you, Anshu?
Yes, ma'am.
Okay, so let me introduce myself once again. I'm Jyoti Sharma and I'm the teaching assistant for the course Conservation Geography. And I will be taking your classes from 6 to 8 on Sunday, the live classes where you can like solve your queries and you can ask the question whenever you get the problem. Okay. So let's start with some like questions and answers so that we can get the knowledge in depth. Okay, so I think in that three classes that sir took. So in first class he taught about that how the planet, how the earth, how the star formed. Then in the second session he I think explained the structure of the earth and how the earth evolved. And in the third lecture he taught about like what's the feature of the earth. Okay, so let's start with the Big Bang Theory. Okay, so what is the Big Bang Theory? Can anyone please explain? Anshu can explain because Anshu has a geography background, right? Anshu, Anshu, what's the Big Bang Theory? Anshu, I'm audible. Okay, Mayank, do you know like what's the Big Bang Theory?
Uh, I would explain it like
Yes.
it is a theory that explains that how planets were formed, how our solar system got formed. It all
But
started
before that, how the universe is formed, right?
right now.
Okay. So, so what's the Big Bang theory? It's a kind of model of the universe birth, right? And this theory tells that in 13.8 billion year ago, that space was just a single point. Okay, and this single point has a very high density and very high temperature, and within a second this point exploded very rapidly in such a way that universe formed in every direction. Someone want to join, I think. Yes. So the first thing you have to keep in your mind that this Big Bang theories tells that universe is formed 13.8 billion years ago. Okay, the second point you have to keep in mind that it was a single point from where this universe is formed, and this single point has very high density and has have very high temperature, from where this energy, like a huge energy, was released 13.8 billion years ago. And we know that this energy can be converted into mass from the equation E is equal to mc square, where E is equal to energy, m is equal to mass, c is the speed of the light, and the square of c. So this energy can be converted into mass. So this universe is formed when this energy was converted into mass. Okay, so but the temperature was so high at that time, then this electron, proton, and neutron could not come together, because because every this electron, proton, neutron has a very high energy that they couldn't come together. Okay, because every this every element, every this particle has a very high energy. So but after 3 lakh year, this temperature below down this 4500 Kelvin, and after only after that atoms started to form and galaxies formed. So I think this is clear to all, like what is Big Bang theory. Has joined this class. So, is it clear, Anjali, that what is Big Bang theory?
Yes, ma'am.
Okay. Now, after that, because we now know that universe has been formed, but some stories has been there that how it can be possible that that there was a single point and then after that it exploded and the universe has been formed. So there were so many like stories behind it. There were so many critics like how this can be possible. So scientists started to collect some evidences. Okay, so evidences of the expanding universe. Okay, so what are these evidences? We will start from 1912 to 1930. What scientists like did and how they got to know that the universe is expanding and this expanding universe is also known as the Big Bang theory. So the first in 1912, Vasto Sleeper, this he was the scientist who told that because the galaxies are going away, so these galaxies are emitting the red light. Okay, so we are like these galaxies light is red shifted. Let me explain more about this, what this red shift is. As we know that like this is our visible light, and visible light, the range of this visible light is 400 nanometer to 700 nanometer or 800 nanometer approximately. And this start from violet, then this indigo, blue, green, yellow, orange, red, we know is at a Vibgyor. And this violet has a very high frequency, and this frequency decrease from violet to red. Okay, and because this frequency is directly proportional to energy, energy is also decreased from this violet to red. But opposite to it, the wavelength increases from violet to red. Okay, so as the galaxy go away from our eyes, like if it is going away, then what will happen? The frequency will be decreased. Frequency will be decreased. It means the wavelength will be increased. So whenever the galaxy is going away from us, the color of the wave will change from here, this violet, then indigo, these to red. Okay, so whenever there is a larger distance, then it the galaxy will create the red light. That's why we are calling it the red shift. Okay, and whenever the galaxy is approaching us, like it is coming near to our eyes, then the frequency will be higher, and yes, the color of this wave will be violet in color. Okay, violet or either violet or blue in color, because these are the high frequency range. So because galaxies are going away, then the light color is shifting from this violet, blue to red. That's why this is the one of the evidence that says that the galaxies are moving away from each other. And how these are moving from each other? Because this is the expansion, universe is expanding. So this red shifting of the light is also known as the Doppler effect. So everyone is clear about this, what is Doppler effect, and how this red shift can be the one evidence of expanding universe. Mayank, is it clear to you that how
Yes,
this
ma'am.
red shift? Okay, thank you. Then okay, this was the first evidence. Then in 1922, Alexander Friedman also provides some theoretical evidences that universe is expanding. I don't know what was the theoretical evidences, but if you want to know, let me know that in the next class I will tell you like what will be the theoretical evidences. But yes, in 1922, Alexander Friedman provided some theoretical evidences. If you know, you can tell me like what these theoretical evidences were. Okay, because I don't know about this. I have to read more about this. Okay, then in 1927, George Lemaitre identified that recession means uh, uh, galaxies going away, can be explained by the theory of expanding universe. And yes, we can explain is as you can see, if we have a like small balloon, and if we pump it, the two if there is a like we mark two places after blowing, the distance between these two places will be increased. Okay, so yes, the expanding so we can think that like two distances are going away from the each other, because the balloon is expanding, right? And balloon is just like the universe. If the universe is expanding, then the galaxy is also going away from us. This is just like the, if we just if we are increasing the volume of a balloon, this is just like that. So in 1927, Lemaitre identifies that these galaxies that are going away, that can be explained by the theory of expanding universe. Okay, then in 1929, an experiment was done by this Edwin Hubble. Edwin Hubble, what he did, he used a that astroscope, in which he just targeted some galaxies. Okay, and he tried to find out the distances of the galaxies, and the speed with which these galaxies are going away from the us. Okay, so he tried to find out the relation between the distance of galaxies and the speed with which they are going away from us. And there were a direct relationship between these two. We can say that the distance to galaxy is proportional to the recession velocity. And how, why this is happening? Because if something is away from us, then we observe that the velocity is higher with the distance. So this type of experiment was also done by Edwin Hubble, that gave the evidence of this expanding universe. So I think the evidences has been cleared to all of you and this Big Bang theory. Now we will start with how the star form. Okay, so we have to keep in mind two things. The one is what is nebula, and second is what is protostar. So what is nebula? Nebula is a, like, initially there were a cloud of gases, and these gases were nothing but hydrogen and helium, and some dust was also in space. So this cloud of gases and dust formed the nebula, and this nebula are the birthplaces of the stars. Okay, so whenever you talk about like star, planet, every time you have to talk about the nebula, because the star, planet, everything start from the nebula only. Okay, then what is the protostar? Protostar is the early stage of star formation, where nuclear fusion is yet to be begun. Because to be a star, there must be two things. The first thing is the core must be very dense, like the compaction of the core must be here. Okay, the second thing, to be alive, the nuclear fission is must. Okay, because without nuclear fission, the star will not get the energy. And how this compaction will be formed? This compaction will be formed due to the gravitational force, because gravitational force says that F is equal to G m1 m2 upon r square. So if the two bodies are like very near to each other, then there will be higher gravitational forces. Okay, so in the nebula there were so many gases. So if these gases are coming together, and the distance reduces, so the gravitational forces will be very high, and as soon as the distance is decreasing, gravitational force will increase. So this will increase the density of the core of this nebula, because core has been formed due to the gravitational force, and because most of the molecules has been come together, and these molecules are nothing but the hydrogen and helium, so they will fuse together. The hydrogen and hydrogen will fuse together, and the nuclear fusion will be happen here. Okay, if the nuclear fusion is happen, the energy will be released, so this will lead to the formation of star. So for the formation of star, we must have two or three things. The first, the material, we must have material. What way is the material? We must have the nebula. Second, we must have the gravitational force. Third, we must have the nuclear fusion to get the energy to form the star. Okay, so these three things are very compulsory to form a star. And whenever this hydrogen and the energy get depleted and finished, then we can say that a star is dying. Okay, and yes, if hydrogen, if we have the energy, if we have hydrogen is mixed, hydrogen is like fusing, it is making the helium. If helium is also like helium is getting reaction with another hydrogen or helium, it will create some heavy elements as well. So because of this hydrogen and elements, the formation of different elements also happened at that time. Okay, so I think this is clear, all of you, right? um, I,
Yes, ma'am.
okay. Okay, so this is one I got from online website where it shows the like how the star life cycle goes, like from average star or from nebula to white dwarf or black hole. Okay, so it start with the protostar. Protostar. I just told you that protostar look like a star, but because it is not hot enough for the nuclear fission, so core is not very dense at that time. So this is the protostar. After that protostar, the this fusion take place, and because of the fusion in the core, it will form the star. Okay, it can also, it can create the large star as well as the small star. Then this star, there is a different stories, like what happened if the hydrogen is depleted, if there is no any hydrogen for the fusion. Okay, though, so star will be degraded in the nebula itself, or in the white dwarf, or in the black dwarf. So, and if it is happen that this fusion is happening in the shell area, not in the core area. Okay, so this will create the star into uh, a giant star, red supergiant star and red giant star. Okay, and after that, because there will be no further fusion, that it will just destroy into the nebula or the supernova. So this is whole story of the star. Now the question is, how did planet form? So planet also start from the nebula, but yes, it develop around the star. So a rotating disk of gases and dust. Someone wanted to join. Let me. Yes. So, a rotating disk of gas and dust develop around the star. So, we can see here the first step. The stars are the localized lump of gas within a nebula, as we already have discussed. So, the gravitational forces within the lumps lead to the formation of core of the gas, and a huge rotating disk of gas and dust develop around the gas core. So we can say, see here, this is the round, this is the round mass of gas, and around this there is a disk. This disk will form the planet after some stages. Okay, so in the second stage, the gas clouds start getting condensed, and the material around the core develops into small rounded objects. These small rounded objects, by the process of cohesion, develop into what it is called planetesimals. Okay, so this plants planetesimals are nothing but a very small kind of planet, you can say, or the small part of the planet that will stick together and will form the planet after a stage. Okay, so larger bodies start forming by collision, and gravitational attraction causes the material to stick together, and these are the large number of smaller bodies. In the final stage, this large number of small planetesimals accrete to form a fewer larger body in the form of planet. So here we can see that in the starting stage a disk is formed. After that disk there is a small mass that is formed, and this some small masses will stick together and will form a planet in different stages. So there is 3 or 4 points that we have to keep in mind for the planet formation. The first is gas will condense, that will form the core, and that will form the star inside. Okay, and in the outer boundary the planet will formed because of collision, the cohesion, and the accretion. Okay, so these three processes will be there in case the planet is formed. If we talk about our solar system, that our solar system has 8 planets, we can say 9 because the Pluto is now the dwarf one. So that's why we are just calling the 8 planet. So if we talk about this 4 planet, these 4 planet are the terrestrial, either or rocky, or the inner planet. And what are these? These are Mercury, Venus, Earth, and Mars. And can you see that these lines are nothing but these are the solar winds, and these solar winds just destroy or let the gases around this planet go away. Okay, that's why these are terrestrial or rocky in nature. But because this solar wind is not much enough or strong for these planets, so that's why these planets are formed of gases. These are not of the like rocky form. Okay, so and because solar wind is letting the gases away, the size of, and because of high temperature, the size is also very small of these 4 planets. Okay, so I think it is clear why these planets are being called as terrestrial or rocky or the inner planet. Okay, because of solar wind and high temperature this happened. The later 4 planets are known as Jovian. Why Jovian? Because these 4 planets are just like the Jupiter. That's why these are known as Jovian. Gas giant because they are formed of gases only, or the outer because these are inners, and the later 4 planets will be outer. So these 4 planets are Jupiter, Saturn, Saturn, and Neptune. Okay, so I think you are cleared with our solar system, what we have right now, and where the Earth is, like at what position the Earth is. Can someone please tell?
And third,
Third, yes. So we are at the third position, in such a position where we have the atmosphere, where we don't have that much temperature that we can survive. And yes, we are at the best position that the living things can be survive very well here. So let's talk about how did Earth evolved. Okay, so we already have talked about the how universe formed. We talked about how the star formed, and then the planet formed. Now we will talk about Earth only. Okay, so how the Earth evolved. Initially, Earth was nothing but very hot and molten mass. Okay, and because there were so many asteroid and meteors that were bombarding with the earth continuously, and because of that bombardment, the temperature is very high of this earth. Okay, so earth was very hot and heated because of three reasons. The first is gravitational compression was going on. Every time the gravitation was working and core was getting dense every time. So the first thing, why the earth was heated, it was due to the gravitational compression. Okay, the second reason was radioactive decay. Earth has some material in it that are radioactive in nature, and these radioactive material can decay in such a way that it produce some heat. Okay, so because of radioactive decay as well, the earth was very much heated. The third, as I already told, that the asteroid asteroid and other planetesimals were there that were bombarding with the earth, and because this potential energy was being converted into thermal energy, and thermal energy is nothing but the heat. Okay, so because of the bombardment of these asteroids, the earth was getting heated. Okay, so because it was heated due to gravity, that heavier metal sink to the core area. So whatever the heavier metal we had, like the iron, the nickel, and these metal were synced to the core area, and now also it is present in the center of the earth. Okay, with the cooling, the outer crust was formed. Thus we got a differentiated layered structure of the earth. Okay, so if someone wanted to join, let me. Superior Patra. So if we have this globe and we take one chunk of this globe, and something happened. Yes. So we will see that outer is the crust area, that below this crust area is the mantle, then the outer core and inner core. And if we explore this chunk more, then this is the structure we will get. This structure says that we have the oceanic crust here. Then we also have the like continental crust here, and the layer that is dividing this crust to mantle is the Moho discontinuity. Okay, so you must know this terminology, that crust and mantle is being differentiated by a layer. That layer is known as Moho discontinuity layer. Okay, and some part of this crust and the upper part of mantle will create an asthenosphere. This asthenosphere is the region from where the magma comes. Okay, so this is very important, like because this asthenosphere is only the region on which the plates of our earth move. Okay, so you must have to keep this into mind. If we talk about the lithosphere, then yes, I told it, I think this crust and uppermost layer of this mantle will create the lithosphere. Asthenosphere is the part of the mantle that is upper part of this mantle. Not upper, but yes, from uh, from 300 kilometer it start asthenosphere. Okay, so we also divided mantle into two part. This is asthenosphere and this solid mantle. Okay, and this mantle and core will be differentiated by the another discontinuity, that is Gutenberg continuity. Okay, and this outer core is then can be differentiated from the inner core as well. And you will be very surprised that there is a like alternative form of solid and liquid phase. Like if we talk about this inner, it is solid, then outer core will be liquid, this part will be solid again, this will be liquid again, and this is solid. So there is a alternative phase, like, and it start from the solid phase. Okay. And you will be you must know that as we move from crust to core, of the density of that chunk is increased. Like whatever the here is the density. So for the crust, the density is 2.2 to 2.9 gram per centimeter square. But for the mantle, it increase high in the lower mantle. And if we talk about the inner core, that it increased up to 12.8 to 13.1 gram per centimeter cube. And why this is happening? Because we already discussed here that due to gravity, heavier matter sink to center. That's why, because there is a heavy metal and the center only, that's why the density is higher in the core area. And we have the differentiated layer structure of the earth. So this is well explained here, I think. So this is the structure of the earth. Now we will talk about earth atmosphere composition. Like in thousands of year ago, what was the temperature and what is the temperature now, and what's the gas composition was there in thousands of years ago, and what's the composition of earth atmosphere is now. Okay, so if we start this composition has been categorized into three parts. The first is primordial atmosphere. So in the primordial atmosphere, we had only helium and the hydrogen. And these helium and hydrogen were faded away due to the solar winds. Okay, so initially we had this helium and hydrogen, but we had also the solar winds there at that time. So these were faded away from our atmosphere. Okay, so these were the primordial atmosphere composition. The second stage was degassing of earth, solid earth. So what is degassing? Degassing is nothing but the release of chemical from the earth itself. And these chemicals will create some gases. Like for example, at that time, there were so many volcanoes. Every time there was a volcano on the earth. Okay, so these volcanoes were releasing the methane gas, that ammonia gas, that sulfur gases. So this is degassing. Okay, so the chemical formed, and this chemical will release some chemical formation will release some gases from the earth itself. Okay, so these gases are formed by the earth itself. So at that time, we had the water vapor, we had a lot of carbon dioxide, and this carbon dioxide reacted with the rainwater. And that's why we had the oceanic water with the carbonic acid as well. Okay, then and this carbon dioxide were getting assimilated, were being used by the our acid, our rain. That in the atmosphere, this carbon dioxide was decreasing slowly. Okay, then we had the methane gases, and these gases were mostly released from these volcanoes. Okay, so this is the degassing of solid earth. And then at the third stage, what happened? That photosynthesis started to happen. What is photosynthesis? The green plant takes the carbon dioxide from the atmosphere and release the oxygen. Okay, so after photosynthesis, every reducing gases, what were the reducing gases that had the like hydrogen atoms in it? Okay, so these reducing gases were converted into the oxidizing gases. So this NH3, that ammonia changed into NO2, nitrogen dioxide. This that methane CH4 converted into CO2. That then we had the ozone, then we had the oxygen and the nitrogen. So after photosynthesis, we got the gases whatever the present atmosphere gases are. Okay, so we started from helium and hydrogen, then we moved to the reducing gases, and after that we got the atmosphere what we have right now. Okay, so this is how the atmosphere of the earth evolved from this helium to right now we have a good percentage of oxygen there. Okay, if someone has doubt, anyone can raise your hand and clear your queries as um, as you feel right. Okay, because I don't have any problem if you just stop me in between, right? So you can ask me whenever you feel like you are stuck and you want to clear your queries. So we already have talked about like universe, then star, planet to earth. Okay, so now we will move to how we will know that this rock is that much older and this mountain is that much older. So we will talk about the datings. So before that, I think everything is clear. Mayank, everything is clear to you?
Yes, ma'am, but I had a small doubt that how our inner core is able to maintain solid state at such high temperature, how it is not converting into liquid.
Okay, I also don't know the answer of this. I have to search more. But anyone know the answer of this? Anshu? Anshu, why there is a solid state in the inner core? Why not the liquid state at such a high pressure? Momita, do you know the answer? Anshu, you are not audible to us. I think you are trying to speak, but you are not audible. Okay, Mayank, in the next session, I will try to give you the answer because I,
Ma'am,
yes, Momita.
ma'am, along with high temperature, it is also under high pressure. That is why it can maintain its solid state.
Uh, Mayank, does it clear your query? Like because of pressure, it is maintaining the solid state.
Right, ma'am, now I am able to get it. Thank
Okay,
you.
thank you, Momita, for helping me. Otherwise, I had to explore it more to answer the Mayank question. Uh, okay. Any other question, Mayank?
No, ma'am.
Okay. So should we proceed further?
Yes, sure, ma'am.
Okay. So let's talk about the dating. So there are two ways by which we can date the things. The first is relative dating, the second is absolute dating. So in the relative dating, we try to find out like what was before and what was after. Like we just want to know like which one is older than which thing and which one is newer. Okay, so here it is the relative thing. uh relative dating. So but in the absolute dating, we just want to know like how much old it is, like either it is like 100 years old or 10 years old. We just want a number there. Okay, so this is the absolute dating. So we know right now the terminology, what is relative dating and what is absolute dating. So here there are some principle based on which we do the relative dating. So what are these principle? The first principle is the principle of superposition. So what this superposition says? This superposition says that at the bottom we will have the older rocks, okay, older things, but at the top of this bottom we will get the newer things. So the older thing will be at the bottom, but the newer aged thing will be at the top. So we can say here this one is older, two is the one is oldest, the two is older than this third one, then three we can say it is newer to as comparison to the second one, and fourth is the newest one. Okay, so this is the superposition. The second is principle of original horizontality. So what is principle horizontality? It says that whatever the things we have, the layer, every time the layer is spread only horizontal to the bottom layer. So if this is the bottom layer, then the second layer will be laid out horizontally only, so that we can say this is the oldest one and this is the older and this is the newer and this is the newest. So this is the principle of original horizontality. The third is principle of lateral continuity. So what is this lateral continuity? If we have this structure, and if something has happened in between that, but we know that from this edge to this edge the composition is same. So either there is a cut or something has been happened, we can say that this whole layer is older from this whole layer of this third layer. Okay, so this is the lateral continuity. The fourth one is principle of cross-cutting relationship. What is cross-cutting relationship? It says that if some fault and fold has been happened, if some deformation has been happened, so after deformation something can be formed, like if there can be a seal, there can be a dike that can be formed, but this will be formed after these things. Like we can say that this formation is newer than these things. Okay, so we can say that like this is the oldest one, and these 5 and 6 is the newest one. This is the cross cutting relationship. The fifth is the principle of inclusions. This principle of inclusion says that if there is a inclusion or intrusion of something, like intrusion of the igneous rock, then we will say that because this structure was present already, so this is the oldest one, and after this structure these layers were formed. Okay, so in this case this intrusion is the oldest one, and then these layer will be according to this only after this layer. Okay, so this will be the oldest, this will be the newest. So this is the case of inclusion. And the sixth one is principle of fossil successions. Fossil succession says that because every time there is a new organism, new type of organism, new succession has been take place at the new time. Okay, so we will say that at a different type there will be a different type of organisms That's why, and this organism will die off and will make the fossils. So different time steps will show the different composition of the fossils, and based on these fossils we can estimate what was the time when these fossils were the organisms, and in which era these organisms used to stay. Okay, so based on this fossil succession we can do the relative dating as well. Okay, so I think the principle of relative dating has been cleared to you. Then we will move to the absolute dating. So there are three type of absolute dating. The one is radioisotope dating. The second is thermoluminescence dating. The third is fission track dating. So what this radioisotope dating says, it says that initially we had a parent isotope, and because this material was the radioisotope, after some time this parent isotope has been converted into some daughter products. For example, if we have the uranium initially, after some time, and we know the time, like after the half life, after two half life, this has been changed into let's say plutonium, or let's say the lead. Okay, so we know that initially it was the uranium, then after this much time it has been converted into lead or the plutonium or some other element. So, and what is this half life? Half life is nothing but the time period, how many years it took to just decay the half of the elements. So we can see here there were brown molecules. After one half life, half of these molecules has been converted into the green circles. Okay, so this is the one half life. In the second half life, these green sorry, whatever the brown molecules we have, the half of it will be converted into the green ones. So this will be the second half life. So based on this half life and the decaying rate of a specific element, we can know that what was the age of this element of this or this fossil or this organism at that time. So this is the radioisotope dating. Based on that, we can estimate the age of that thing. Okay. The second is thermoluminescence. What is thermoluminescence? Uh, because of some cosmic radiation or very normal radiation, what happened that in the previous time, the electron got stuck into the lattice of this crystal. Okay, and this create the imperfection. But this doesn't matter it created imperfection or not, but the thing that matters here is that the electron gets trapped into this thing. Okay, because of some radiations. Okay, and more the radiations will be there over the years, more electrons will be trapped into this crystal lattice. But when we will heat this thing, then what will happen, these electrons will be released, and the number of electrons will be directly proportional to the age of that thing, because the higher the number of electrons will signifies uh, the period along which the radiation it has taken. Okay, so this is the thermoluminescence, based on which we can do the absolute dating. The third is fission track dating. So this is based on the radioactive materials. So in some elements, so for example, in the glass, we have in the glass material we have the uranium radioactive material. Okay, so whenever the fission is happening there, it will create some cracks or trails. Okay, so every time a decay is happening, every time it will create some like mark on it. Okay, so the number of mark, the number of folds, the number of this trails will signify the age. Higher the number of this track will be, like the older the things will be. Okay, so these are the three absolute dating. I think everything is clear uh, right now about this relative dating and absolute dating. If someone has some doubt, can clear. Everything is clear. Momita, everything is clear, like what is relative and what is absolute dating and how we can like estimate.
Yes, ma'am.
Okay, Anjali.
Yes, ma'am.
Okay, so we can proceed further. Okay. Now, there are some methods from which we can know the structure of the earth. So, the first is direct method and second is indirect method. In the direct method, we have 2 points. The one is using the volcanic eruptions, like whatever the things will come out from the earth when the volcanic eruption goes on, so we will know the structure of the earth. And second is drilling. Okay, drilling is nothing but we try to get the, like we do drilling into the earth and try to find out the composition of the earth, but because of high density and high temperature we can't go beyond some kilometers of area. Okay, so drilling is not possible to get the core, to get the knowledge of core and mantle, uh, because I told that temperature is very high. Someone also want to join. Okay, so the direct method is volcanic eruption and the drilling, but indirect is by using modeling. The second is structure of meteors and some other celestial bodies, then the change in gravity and gravity anomalies, then the magnetic survey, and some earthquake can give us the information about the earth indirectly. Okay, so first we will talk about what is volcano and what different type of volcano we see in our we see on the earth, and then we will move to the indirect method. So, what is volcano? Volcano is when hot lava, ashes, or gases escape from the magma chamber to the surface. So, this is volcano. And whenever this magma reaches the surface, this magma is now can be called as the lava. Okay, so we have a different type of volcanoes. The first is shield volcano. What is shield volcano? Volcano is nothing but when we have a very like dilute lava, or the uh, low silica content we have in the lava, then it will spread. It will not go very up. Okay, this conduit will not have the much height. Okay, so this conduit will have the very low viscous lava, and it will spread in the nearby area, so this will create only shield like shape. Okay, so that's why it is a shield volcano, and example of this shield volcano is Hawaiian volcano. Okay, the second is composite volcano. Composite volcano is when in place of this low viscous, we have the high viscous lava. Like we have a very concentrated lava. We have very that have a very high density, and so what will this lava will do? this lava will increase the height of this conduit. Okay, and because this is very concentrated, okay, so this will not spread very easily there and where. It will go up, 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 and it will form the composite. Why this is composite? Because this is like releasing some lava here, then after some time it will go up and it will release some lava after some time. So this will form the composite. Okay, so this is the composite. So difference between them is the, like, what is the nature of the lava. If it is viscous, then it will create the, if it is low viscous, then it will create the shield lava, and if it is high viscous, then it will form the composite volcano. Okay, if we talk about the calderas, then calderas are highly destructive in nature. Why these are very high destructive? Because at these are high viscous lava, the first thing. The second thing, at some time this conduit get plugged. Okay, so there is a no way to go out, so the conduit get plugged. Okay, somehow. So if this get plugged, then there will be some gases that will create the pressure on this plug to be like opened up, and it, with the force, it will opened up this plug and will be very destructive, will in a very forcefully it will release the gases in the atmosphere. So this is the calderas, and example is Krakatoa eruption. So was the example of calderas. If we talk about the flood basalt provinces, then this is very high, very low viscous lava, just like the shield, but the here the nature of this lava will be basaltic. The basaltic lava will released from here, and it will spread over the thousands of kilometer of area. So the our Deccan trap in the India itself is a example of this flood basalt provinces. And the last type is mid-oceanic ridge volcano. So this happened in the ocean. In the ocean, there is a convergent boundaries where no there is a divergent boundaries. In the divergent boundaries, something will a new crust will formed, and it will destroy the cider boundaries, and there a volcano is also formed. So whenever there is a volcano formed in the mid-oceanic ridge, we will call it mid-oceanic ridge volcano. An example is the Antarctica, mid Antarctica ridge volcano as well. Okay, so we have talked about this volcano eruption, then we have talked about this drilling. So let's talk about what is like modeling and how we can know the structure of Earth. So in the modeling, we know something about the Earth. Okay, if we know like what is the radius of the Earth, and if we know like what is the composition of Earth, because we know that crust is made of silica, let's say, and we know that magma is made by this, we know sorry, mantle is made by this, we know that core is made by nickel and iron. So we know something about it. Okay, so whatever information we have, we put into the some mathematical equations. Okay, and we try to move this equation in such a way that it can predict something more about the Earth. Like if we want to know the rotation of the Earth in the future, what will be the, like, how this Earth will rotate. So whatever the information we have about the magnetic structure of the Earth, we also know about like satellite of the Earth, that we have moon. So based on some information, we put that information in the mathematical equations, and based on that we have some equations, some partial derivation equation. We try to solve it for the future and try to find out other variables from it. Okay, so this is kind of a modeling. If we want to know about like what will be happen if some meteor bombard with the earth. Okay, so there are a multiple of things that can be happen. Okay, so these multiple things, and what will be the effect of this meteor bombardment? Like there may be volcano like situation, there may be earthquake like situation, and if there is a volcano like situation, it will change the composition of the atmosphere. And if there is a change in the atmospheric composition, definitely they will change the vegetation type or something like that. So everything, like most of the thing is trying to be predicted by the equations and models. Okay, so these type of things are incorporated in the equations, and we try to find out the future structure of the earth after some happenings or after some years happenings. Okay, so this is kind of modeling. And yes, if you know that it may be that our model is not so much good, that it is not predicting very well, so we try to correct it, we try to tune it correctly. Okay, so because as I work in the climate modeling, so I know that not every model is correct and every model can't be perfect, but we rely on the modeling just because we want to know about something about the future, and this future information can be only given by the modeling things. Okay, so this is the models. The second is the structure of meteors and other celestial bodies. So because we know that these meteors and the formation of earth, the composition is almost same. So whenever we get the meteors, the structure, we try to get the structure of these meteors, because this is very much match with the earth structure. Okay, so we also study the meteor for that region only. Third, the change in gravity. So this is also the another indirect way. If there is a changing in the gravity of the earth, either in crust or mantle or in core, so we try to find out like why this is happening. We try to find out, based on this gravity, we try to find out the structure of the earth. Then same like gravity, there is the magnetic surveys are being done. Based on magnetic surveys, we can try to find out the structure of the earth. And then earthquake, um, earthquake and seismic activities, because this earthquake will emit some waves, just like P waves, S wave, surface wave. These waves have some properties. Okay, and when these waves travel, it will carry also the property of the earth, and the movement will be based on the property of earth itself, the structure of the earth itself. Okay, so whenever the wave moves, it give us the information of the structure of the earth also. So these are the indirect ways by which we can get the structure of the earth. Yeah, volcano has been cleared. Okay, so let's come to a very interesting topic, that is continental drift theory. What is continental drift theory? Can anyone please explain, because this is very interesting and someone want to like discuss it before I explain, like what is continental drift theory? Anjali, can you please explain? Anjali? Harsh? Harsh? I think Harsh is not here. Mm, okay, Mayank, I think you know about this. Like, what is this continental theory?
Ma'am, this theory says that once upon a time in past, all
Uh,
continents were together, they were grouped, and a single chunk of land was present. And due
yeah.
to some factors, they drifted away, and today they are seen as seven different continents.
Okay, so is this theory is correct or not?
And based on the evidences, it suits well.
Uh, but some new theories came into picture, and this theory was like this theory is now not in not very exact.
Okay, ma'am, I didn't know about that.
Okay, so we will discuss about it because it was not the continents that were moving, but these were the plates that were moving. Okay, so these were the plates that were together at one time and that were like drifting away from each other. So it was just like that. These were not the continents, but the plate itself. That's the only difference that I think you must have known, but you couldn't explain now, है ना?
Right, ma'am. Underlying plates were moving, not the continents.
Yes, exactly. So these were the new theories, and these are the correct, but the continental drift theory is not correct. But yes, evidences were like yes, this were kind of like from upper view we could say that yes, this is right. But if we study deeply, then we can say that yes, the other theories are far better than this continental theory. Okay, so let's start with this continent theory. So in 1969, sorry, 1596, the Abraham Ortiz told that this America, Europe, and Africa were joined together. Okay, and the basis of these things were that there is some matching, like there is the jigsaw fit of that area, but he couldn't collect some evidences based on that he can say that these were together. Okay, so everyone just ignored whatever the Abraham said. Okay, but in 1912, Alfred Wegener told that the continents were together at one time, and this supercontinent or all Earth, he gave the name Pangea. Okay, and so this is the region what he called the Pangea region, and the mega ocean and all sea region, what he gave the name was Penthesilea. Okay, and this Pangea was divided into two parts. The northern part was given the name Laurasia, and the southern part was given the name Gondwana. Okay, and this this Gondwana part and this Laurasia part, like this Pangea was initially together. Okay, after that it's split it into two parts, the northern and the southern part. So these splitting was happened in the Triassic era, and this Triassic era was 200 million years ago. Okay, so and he collected some evidences as well. So there was like he collected evidences just like jigsaw fit, then same rock configuration, then the marine deposit, delite, gold, placer deposit, fossil. We will talk about it one by one. So let's talk about this jigsaw fit. This jigsaw fit tells about, can you see like the structure of this Africa can just fit the structure of the South America. So this is the matching of the continent outer layer. So this was the first evidence he gave, that the matching of the continent can be done, and because this is matching only possible because they were together once upon a time. Okay, so the first thing was that. Second, same rock composition. So whatever the rock composition and age of the rock was in, like, South America, uh, the same composition was found in the Africa also. So how can it be happen, like, very same age and the very same rock composition can be found in two continent? How can it be possible? It is possible only when these continents were together, and the rock were formed then only. Okay, so this is the same rock composition was found in different continents. If we talk about the marine deposit, okay, so this is also, there is some fossils, there is some marine deposits that were found in different continent but of the same composition. Okay, so this is also the uh, example or the evidences that the continents were drifted after a time, and before that they were together only. Then we have the tilites. What is tilite? Tilites are the some sedimentary rocks of the glacial glacial structure. Okay, so these sedimentary things were also found at the different continents but of the same composition. So this was estimated that the continents were together at one time. Then this was very interesting, that this gold placer deposit, like, we have some traces of gold material at one place, and this gold, the deposit of this gold was not present at that continent as well. So how can this gold material or the traces of gold can be found at that place where there is no such deposit? Okay, so it was just estimated that initially there were, like, continents together, and river must be flowed between these two continents, and the gold used to flow in that river, and that's why this the trace of gold can be found in that continent as well, where there is a no deposit. Okay, then some fossil records we can see here, like, how can the how can this suppose Mesosaurus can be found in the Africa and the Antarctica? The habitat can't be that much diverse. Okay, so this is only possible when these were together. So these are some evidences. Based on that, we can say that it was the continental drift that make the continent away from each other, but once upon a time they were together only. And when some scientist or some geography people asked, like, how can this possible that continental drift can be happen, what are the possible causes? So Wegener didn't have the clear idea of the causes of the continental drift, but he gave some lame answers. So he gave 2 points. The one point is, there must be the tidal force because of which the continent were drifted, and this tidal force is because of the attraction between sun and moon. Okay, the second cause he gave, that it is the centrifugal force, or what it is, pole fling force, that is formed due to the earth, and that make the continental drift. But scientists also calculated the force magnitude, and how this how much time it will take to drift the continents. So they just estimated and they just denied these things, because these forces are very low in the magnitude that they can't drift the continent in such a short time, because it take more than whatever time it took to drift the continents, and it can't be happen just due to the tidal force and the pole fleeing force. Okay. So the continental drift was not discarded, because Wegener gave some evidences, but yes, everyone has some doubt, because the causes of the continental drift were not very clear at that time. Then then a person, Arthur Holmes, told that this convection current in the earth mantle due to the thermal differences can cause this continental drift. Yes, this was possible, but uh, we had to explore more about the earth before agreeing that yes, it was the continental drift or not. So some new inventions were happened after that time, to get the knowledge of this continental drift and why these continents are going away. Okay, so the one of the big new invention was the configuration of the sea floor. Sea floor has been explored in the time of World War Second. Okay, so in the World War Second, it was explored, and we got to know that sea floor is just like the crustal floor. It also has some mountain, it also has some trenches, it also has some rift valleys. So we didn't explore it much before that time, and we got to know that yes, it is very similar to the crustal floor. It has all the feature whatever we have on the earth. Okay, so and yes, we got to know that there is a mid ocean region there. Okay, so this mid oceanic ridge is formed whenever this mid-oceanic ridge is forming a new structure in the sea floor. Okay, so and it is creating some mountains like a structure there in the sea floor. So this is the first thing we got about the sea floor first time. Okay, the second thing we got about the oceanic floor is the magnetic reversal strips. As we know that our geographic pole is very much different from the magnetic pole. Like if we have the north magnetic pole, then the geographic, it is a south pole, and the vice versa. So and we also got to know that yes, oceanic floor also have the magnetic reversal strips. So we are just comparing it with the crust, and we got to know that yes, sea floor is very much similar to the crustal floor. Okay, then we got to know about the distribution of the earthquakes, and we got to know that these earthquakes are has a very specific location. Okay, so we can see that there is a line where the earthquake is very high. Like this is the line where earthquake is very high. So why this is happening, the scientists try to get the answer of these questions as well. Why there is a that specific distribution of the earthquake, why this is the why there is a specific location of the earthquake. So this type of questions, this type of answers will lead to the theory of the plates. Then the distribution of the volcanoes, we can also see that there is a high volcano near these structures only. Near these structures there are this volcano distribution is very specific. Like why this is specific, everyone tried to get the answer of this, and while getting the answer of this, we came across about the plates and the plate tectonics. Okay, Then the very much interesting concept that we got is the seafloor spreading that was given by Hess in 1961. And this seafloor spreading theory told that because at the center a new a new crust is formed. Okay, and this crust formation is going in the right direction and in the left direction, and it is creating a mirror symmetry. Like if there is the youngest crust here, then it will the youngest crust will there as well. If there is the older crust, then there will be the older crust. And yes, at the center there is the youngest crust, and if we are going away from this, we will get the older and oldest crust. So why is this happening? So scientists estimated that yes, some new crust is being formed at that area, and that new crust is pushing the older crust, and it will create the newer crust in that area. So uh, we got to know that there is a similar composition and age on both side of mid-oceanic ridge. The first thing. The second thing we got, that the oceanic crust formation at the mid of this. Then we also got to know that the older crust is being destroyed because the newer crust has to replace it. Okay, and we also got to know that volcanoes are being happened in the subduction zone. So what is the subduction zone? Subduction zone is nothing but where the crust is being destroying. Okay, so whenever there is a crust is being destroying, there is some like pressure is being created, some gases are being released. So based on that, volcanoes are creating. So we got to know about such things about the ocean, and this will lead to our plate tectonic theories. So after that, plate tectonic model was come forward, and it was given by Mackenzie, Parker, and Morgan in 1967. And in this model it was said that this plate there is the plate tectonics. That plate tectonics, what are these plate tectonics? That are lithospheric plates that are very massive, that are irregular shaped slab of solid rocks, and these are generally composed of continental as well as the oceanic lithosphere. And these plate moves over the asthenosphere, often horizontally. Okay, and this movement of plate is also associated with the young fold mountains, ridges, trenches, fold, volcanoes, etc. Okay, and here, and why these plates are moving? So we had the reason for that. We knew the driving factor. What was the driving factor? The creation of convection cell drives the plate movement, while slow movement of hot, softened, semi-solid, and liquid metal below the plate. So after that, we got to know that these were not the continents that were moving, but these were the plates that were moving, and these are moving right now as well. And in the ocean, the in mid-oceanic ridge, a new crust is also forming, and if new crust is forming, the older crust has to be destroyed, and it is destroying in the subductive zone. Okay, so we have some like we must know some the names of the major plates and the minor plates. So let's see, this is the Pacific plate. Pacific plate is mostly have the oceanic crust. Okay, and we can also see the direction here. Either these plates are moving closer to each other or going away from the each other. Okay, so if we have this Pacific plate and that the Nazca plate, so these are moving apart to each other. These are creating new crust. because they are moving apart to each other. So this is the Pacific plate. Second is the North American plate. So this is the North American plate, if you can see my cursor. Then we have the Eurasian plate. So want to join or something like that. Let me see. Yes. So this is the Eurasian plate, Europe plus some part of the Asia. This part is the Eurasian plate. Then we have the African plate. African plate have both the oceanic as well as the continental crust over it. Then we have the Antarctic plate. This is the Antarctic plate, the whole plate. Then we have the Indo-Australian plate, this part, Indo-Australian part. Then we have the South American plate. So these name of the plate must be on your fingertips, like what are the major plates and where they are, where they are. Okay, so we have 7 major plate: the Pacific, the North American, the South American, then we have Eurasian, African, Antarctic, and Indo-Australian plate, that are the major plate. If we talk about some minor plate, because they are very small in size, so we have this Cocos plate, and this Cocos plate is in between this Pacific and the Central America. Okay, then if we talk about this Nazca plate, then it is between the Pacific plate and this South American plate. The third is Arabian plate. Then this is on the Arabian landmass. If we talk about this Philippine, this is the Philippine. This is between the Eurasian and the Pacific plate. And this one is Caroline. This Caroline is between the Pacific and the Indo-Australian plate. And these are like, we have some other minor plate as well that I didn't discuss, that just like Fiji plate and this Bismarck plate. You must know about these names and where these plates are. Okay, so that and we must also know the nature of these plates, like two plates are going away from each other, or they are convergent in nature, like coming together. If we see here in the mountains region, in the Himalayan region, we will see this Eurasian plate and this Indo-Australian plate is coming coming closer to each other, and it will create the destruction of the crust, or it will form the mountain like structure as well, because some pressure is coming from both sides, and this will fold the things. So the fold mountains, just like the younger Himalayas, will form in such a case. So we must know that these two plates are coming together at this position. That if we talk about the mid-oceanic ridge, and this here the Nazca and Pacific, these are going away from each other. That's why we can say that new crust is being formed here. Okay, some plates are like, if this is going this side and this is going this side, like these are sliding to each other. Okay, so this will create no such effect like destruction or the creation, but we will get more about this sliding boundary as well in the future. So these are the major plates and the minor plates. So because we know about these plates, now we know that these are the plates that are moving but not the continents. And because each plate is close to each another, so if one is moving somewhere, it will affect the other plate. Okay, so we must know the nature of the boundary of this plate as well. So there are 3 type of boundaries that we study. The first is divergent. What is divergent? Divergent is like if two plates are going away from each other. So if they are going away from each other, the asthenosphere lava will come out and it will create a new crust. Okay, so the example is mid-Atlantic ridge, and this will this is the spreading center. Okay, the second is convergent. So what happened in the convergent? Here we can see the convergent. If two are coming together, like coming close to each other, then one has to be go down and one has to be destroyed. Okay, so this is the subduction zone, and example is where the Himalaya is being forming, that is the convergent boundary. And here it was the spreading center, but here it will be a trench. Okay, the and this convergent boundary can be convergence can be of three type: oceanic continental convergence, like it can be possible that there is a uh, there is the ocean one side and continent at the other another side, and these two plates, one is of oceanic and second of continent, is being converging. Okay, it can be oceanic convergence, or it can be continental convergence. So these three type of convergent can be possible under the convergent. Okay, and the third is transformed, where the plates slide each other, like if one is going in this direction, the second is going in that direction. So nothing much happened in this transform, but yes, in the divergent and convergent, the destruction and the creation of the crust is happened, and this explain the plate tectonic model, as well as like how the plates are moving. uh, Now we have some old assignment questions. I will ask the answer of these questions from you only, and the explanation of explanations. So let's start with the first question: which of this is true about p waves? The first option is they are longitudinal in nature. Second option is they are transverse in nature. The third is they can't move through gases. The fourth is they can't move through liquid. So who will tell me the answer of this question? Um, Anshu, what's the answer of this question? What is true about p waves? Anshu, your voice is not audible.
Ma'am, they cannot move in liquids.
Yes, now you are audible. Can you tell me the answer?
Ma'am, they cannot move in liquids.
No, actually, P waves are very strongest in nature, that can move in the three phases. Like it can move in the gases, it can move in the liquid, and it can also move in the solids. Okay, so because P wave can move in the gas, in the liquid, and in the solid as well, so we can cut out the three and fourth option. So we have only one and second option. So try to tell me the answer from this first and second option. What can be the right answer?
Ma'am, P waves are longitudinal waves.
Yes, exactly. So these P waves are the longitudinal in nature, because these are just like the sound waves. Okay, so how sound waves moves? They are moving like uh, they are moving. I can make the structure, but these are just like the sound wave, and sound wave move move in just like a p wave. So the movement is longitudinal of the sound wave. So we can say that p wave are also longitudinal in nature. Okay, so the second question is, Deccan traps are an example of. Anjali, can you give the answer of this? Deccan traps
Ma'am,
are the
sealed
example.
volcano.
Which one?
Sealed volcano. One.
Shield.
Yes,
No,
ma'am.
no, this is not shield, but the flood basalt provenances, because Deccan traps, like in India, uh, the lava of the basaltic nature spread over a thousands of kilometer, and that that is an example of, like, whenever a basalt is spreading over a region, then we called it is a flood basalt province, and the example of this is the Deccan traps. Okay. Okay, now the third question: which of these is a gas giant?
Ma'am, Saturn.
Yes, you are right. So why it is Saturn?
Because it is made from gases.
Yes, and why it is made from gases? Why Mars, Earth, and this Venus are not made up of gases?
Ma'am, these are Jovian planet.
These are Jovian planet, and we can also say that because these are away from the sun, these are away from the stars, so they don't have the high temperature, they don't have that solar wind that the Earth, the Venus, that Mars face. Okay, so because of that wind, that high temperature, that gas will be escaped from these first four planet. But because these these later four planet, the gas can be maintained there, because there is not that much high magnitude solar wind there, or the high magnitude temperature is available from the sun. That's why gas planet can be formed there only, but they can't be formed in the very near to the sun, such as like Mercury, Venus, and Mars can't be the gas giant, right? Okay, the last question: which of these is an example of
Volcanic
direct source of
eruption.
information? Yes.
Volcanic
Volcanic eruption.
Yes, we talked about it, that it is the
vol-
volcanic eruption that give us the direct information of the earth. So why the volcanic eruption, not the earthquake or the magnetic or gravity anomaly?
Ma'am, because we can't see earthquakes and magnetic survey at sea.
Yes, and whatever the waves, whatever the information we are getting from the waves, it is indirect only, na. So we are not getting the structure of the earth directly from here, but in the volcano we are getting like whatever the material is inside the earth, we are getting it from the volcano. Okay, so we want to know about the structure of the earth, and volcano is just giving us that material of the earth. Okay, so this is the direct. And what was the second uh, um direct method from which we can get the information?
Then killing.
Yes,
Modeling.
with no, modeling is the indirect method. Like, we just put some equations, and based on that equation we try to find out the future. We can try to find out what's inside the earth based on some information that we have. So this is just the indirect method. So modeling is the indirect source of information that we get from the earth, about the earth. Okay, so actually, we had more assignment question, but these questions right now I think you have been given for this second week. So that's why I just put four question and answer session here. So I think this has been completed. So any doubt from any slide If anyone has, you can ask or raise your hand. Like we talked about the Big Bang theory, how the universe is formed. Then we talked about how the star were formed. Then we also talked about like how planets were formed. Then after planet we came to the earth part, then how the atmosphere of the earth was formed from, like what were the three stages, like from the primordial to whatever the atmosphere we have, we discussed about it. Then we also discussed about the structure and the evolution of the structure of the earth, and whatever the structure, whatever the different layers we have of the earth. Then we also talked about that dating, like how we can date the things using the relative dating as well as the absolute dating. And in the relative and absolute dating, in the relative dating we mostly talked about the principle. Based on that principle we can just give the answer which one is older and which one is newer. Then after that we talked about three different type of the absolute dating. The one is radioactive dating, the second is thermal luminance rate dating, and the third is the track emission dating. I think the I don't know the name of third, right? So these were the third three type of dating we studied about. Then we came to know about the continental drift theories. Continental drift theory told that yes, it was the continent that were moving apart from each other, and also Wegener gave some evidence of this as well. But after knowing the sea floor region, after knowing the earthquake, the volcano location and everything, we got to know that yes, the crust is being formed, the crust is being destroying, and how this is happening. See, so we also got to know about the plates. So these were the plates that were moving away or close to each other, that's are either of either destroying some crust or either creating some crust. And also like the mountains, the folding mountains, the youngest we have the Himalayan. So this is the result of the uh, convergent boundary that our mountains is being, the height of mountains is still increasing, and it is very youngest in age as well. So we also talked about and these kind of things. Then we also talked about the volcanoes, what are different type of volcanoes, and what's the difference between these volcanoes. I don't think that we studied very much at length about this earthquake, but if you want to know more about the earthquake, then yes, I can explain it more in the next lecture. And what else we discussed today, I think that's were the things. And then the old assignment question we also discussed here. So what else you think that we should discuss here? Or everything, like the someone who watched the last week videos of Dr. Arun Avadia, then don't you do you feel that something is missing and we must have to finish it in this current lecture or not? Mayank, can you tell me like what topics has been left, and what we should have included in this lecture?
Ma'am, the lecture was very well covered, but I think uh, S waves, P waves, they could have been
Okay, okay, about the earthquake, right?
right, ma'am.
Yes. So I will try to cover it in the next lecture.
Sure.
Okay. Okay. What else that has been you thought that you must know it in, like at length? You must know it very deeply. So what are these different topics you can suggest me?
Ma'am, other than that, I don't think there was any topic left.
Okay. Okay. Thank you, Mayank. Anjali, everything is cleared from your point of view?
Ma'am, is there any video there?
Anjali, some background noise is creating your voice very down and harsh.
Ma'am, is
Anjali,
there any previous year question paper for us in
is there
conservation geography?
what I didn't get your question. Can you write it in the chat box so that I can get what was your question? Anshu, is everything clear? Anshu? Okay, I think this must be the dinner time of the BHU girls. So they must have gone. Uh, uh, Mayank, is everything clear?
Yes, ma'am.
Okay, so uh, so she just asked me the question. Is there any PYQ in conservation geography from which we can prepare for upcoming exam? Anjali, I want to know that what this PYQ is.
Ma'am, previous year question.
Okay, previous year question. So, see, I have the access of old assignment questions. So, yes, if because sometime what happens that if the 10 assignment question has been given to you every week, so if the question has been like given to you in this current semester, uh, it may be that from the previous year's assignment 4 or 5 question has been given in the new assignment, so I can't cover that questions. So this time, because out of 10 questions 6 questions were asked in the current assignment as well, that's why I had to cover only 4 questions. But uh, no, I don't have the access of as such that previous year question bank. But yes, I have the access of this assignments questions. So based on whatever the question has been asked by Avadhya sir this week, I tried to cover that. Whatever the question has been not asked will be covered in this session only. So I think this is the only access I have. But I will try to let you know, like if they can provide you the previous year question or not. I will ask about it, Anjali. Okay. Yes, Rakesh, what's your question?
गुड इवनिंग मैम।
Good evening.
मैम मैंने इसमें कोर्स में जो है पहले रजिस्ट्रेशन किया था, असाइनमेंट वगैरह सबमिट हो चुकी है, लेकिन एग्जाम के बारे में कोई इंफॉर्मेशन नहीं है मेरे पास।
एग्जाम के बारे में आपको क्या डेट वगैरह नहीं इंटीमेट किया था कि किस डेट को? अच्छा, क्या आपने सर्टिफिकेट के लिए फीस दिया था?
फीस तो नहीं दिया मैम, इसमें फीस का तो वो था नहीं, मैंने पहले किया था ये अप्रैल मई में किया था ये कोर्स कंप्लीट, असाइनमेंट वगैरह हो गई थी, उसका रिजल्ट भी
अच्छा
आ गया था, लेकिन उसके बाद से कोई इंफॉर्मेशन नहीं मिली मुझे।
था। राकेश, क्या तुमने एग्जाम दिया था या तुम एग्जाम नहीं दे पाए थे?
एग्जाम हुआ ही नहीं मैम, मुझे लगता है एग्जाम हुआ ही नहीं है।
नहीं, एक्चुअली एग्जाम हुआ होगा, बट there is some notification about the certificate course as well. So I think you have to pay some amount to write your exam, if I'm not wrong. I will clear it from the NPTEL team. But yes, I think this will be the problem, that you have to pay something before writing your exam. Okay,
ओके।
so yes. So I think this time some notification are being giving to you people for this certification, and before that you have to pay like I think 1,000 rupees to appear for the examination and to get the certificate, because um, assignment for the assignment there is a no need for this registration and this fee payment, but I think to get the certificate we have to pay some money, and this is I think 1,000 rupees. And yes, before writing the exam you have to pay. So it may be the case that you couldn't pay the amount, and that's why you didn't get the information about the whatever the exam they took, and about the result. So this may be the reason, but yes, I will ask the team about this. Okay, so Mayank told that one must pay 1,000 and register before 18th August to appear in the exam. Yes, that's the what I was also talking about. So you have to pay 1,000 rupees, and yes, please register if you want to get the certificate and if you want to appear in the exam. And so definitely you will get the notification about it, Rakesh. So Rakesh, I think it is clear from my side that for the next time you will be very aware for the exam and the formalities you have to do before appearing the exam. Okay, Rakesh.
Okay, ma'am.
Okay, so I think the syllabus has been covered up to the second week. We will meet again on the Sunday from 6 to 8. So I'm Jyoti Sharma, and yes, I will take your class next week from 6 to 8. Please come and have the discussion so that you can build up the confidence in yourself as well for the next year for the year next year for your future. So yes, we will talk, we will discuss next week. So for now, goodbye, bye bye.
Thank you, ma'am.
Thank you so much, Mayank. Thank you, Anjali. Thank you, Rakesh. So you can leave and have a good night.